Hi, I'm Brad Kerner, and today let's talk about how lighting specifiers can reduce their impact on the environment through detoxifying and decarbonizing lighting specifications. For decades, we've heard leading minds warning of the imminent dangers of climate change. Finally, we're seeing the architecture and construction industry stepping up to address its negative impact on the environment. In lighting, we're looking beyond simple energy efficiency and starting to consider the holistic impacts of architectural lighting, from sourcing materials to production of fixtures to operating them to maintaining them and ultimately disposing of them. And this is really forcing both lighting manufacturers and lighting specifiers to consider their environmental impact. But yeah, what we see is that the legacy lighting manufacturers are largely not acting. They remain frozen in the old ways of designing fixtures, in producing them, and in sourcing their supply chains. So it's really going to fall on the lighting specification community to ask the tough questions, such as why do our lighting products use such energy-intensive materials? Why do they use so many toxic petrochemicals? Why don't project owners hold the lighting industry accountable for life cycle costs? And if we stop and consider for just a second, shouldn't sustainable design and manufacturing lead to radical cost reductions? Why do sustainable options continue to cost more than traditional products? For the 15 years of the LED lighting revolution, the lighting industry has largely been fixated on two metrics: lumens per watt efficacy and cost reductions. And that's led to rampant greenwashing in the industry. William McDonough is the author of the Cradle to Cradle standards, and I love his philosophy that striving for zero is not a noble goal. That what the problem in most industries is they've been on a sort of less bad trajectory in trying to reduce their impacts to nothing, as opposed to striving to create positive impacts on our planet and ecosystems. And it's so frustrating when sustainability is pegged as a sort of tree-hugging hippie philosophy that it's going to cost us profitability, we're going to lose income. But if you really listen to what the leading minds on circular economy are talking about, they're covering things like eliminating toxic materials, eliminating needless components, looking at fast assembly and disassembly, making things repairable and modular for residual revenue streams. This does not sound like a bunch of tree-hugging hippie stuff. This just sounds like fantastic supply chain management. And frankly, what any sort of hardware or hardlines manufacturer should be doing just for basic risk control and profitability. And to really drive this home, when I've spoken at many lighting conferences, I've challenged lighting manufacturers with this question: if your lighting fixtures are returned to your loading docks at the end of life, would they be considered assets or financial liabilities? And sadly, I think most people in the lighting industry recognize that LED lighting fixtures would be considered gross liabilities. They would be nearly impossible to disassemble, and most of the components would be very expensive to dispose of or recycle. So this leads me to a project I did 2 years ago. The United States Department of Energy hosted a design competition called the Manufacturing Innovator Challenge for Sustainable Manufacturing of Luminaires, and I won grand prize. And what I did is looked at the separation of sort of technical and biological materials and really said, why do we need so many technical materials in a standard lighting fixture? Why can't we push more of the material content towards biological, where it takes far less energy to produce and recycle these materials? It has brought up a very interesting problem I've had over the years in product development, in talking to well-intentioned engineers who've argued with me over materials. And generally, they've said that aluminum is a perfect circular economy material. It is durable. It can be recycled endlessly without degrading, whereas wood, every time you process it, it degrades. It's very hard to argue with this, but it never felt right until I started to address the supply chains, and I started to challenge people to say, would you want to live next to any part of that supply chain? In the case of aluminum, would you want to live next to open pit mines? Would you want to live next to smelting facilities? Would you want to live downwind of a petrochemical cracking plant for that powder coat paint, or downstream of an anodization plant? And I think the answer is pretty clear. No. No one wants to live next to any part of that supply chain. Whereas with biomaterials, it's generally the opposite. Would you want to live next to a forest or a wood shop, or a farmer's field where the products are decomposed at the end of life. And I think generally people have no problems living with that. And in fact, many of those are considered benefits to society. So I chose bamboo for the main body of the fixture. It is a quick growing grass, and it has a lightweight harvesting and processing so that it actually sequesters carbon in its mass. It's very good with fire rating, and it is strong, straight, and true. So it can largely stand in for many of the properties that people want in aluminum extrusions. I then found a startup company in London that's making bio-based circuit boards produced from flax waste products, and flax is what's used to produce linen. So if you imagine, instead of some nasty petrochemical cracking plants used to produce the epoxies and the substrates for the circuit boards, our supply chain is a flax field in bloom in the south of France. The next concept is looking at what adds value to the fixture design. This is sort of the lean philosophy of looking at value add versus waste. And in an electric lighting fixture, the core value add is converting electrons to photons. And we have these magical little things called LED chips that do this with unprecedented efficacy in incredibly small size. So really, that's the only thing adding value in an electric lighting fixture. Now, we have a few other requirements, right? We have to give structure. We have to support those LED chips. You might have other value-adding requirements, such as providing architectural decoration or architectural presence. But in general, there's a lot of stuff in a modern LED lighting fixture that is just waste and that we could simply eliminate with a bit of smart design. So then we looked at, well, how do we assemble this? How do we disassemble the fixture at end of life? We chose a design where you can bang out a wood dowel, take the end cap off, and then the LED board and the glass slides out. So the wood can simply be composted, the glass can be easily recycled through any local recycling stream, and the LED board could be repurposed for several more generations of life cycle because it's starting at such a high efficacy to begin with. Then at the end of life, the LED board itself can simply be soaked in water, the electronics can be scraped off, and the bulk of it, the board itself, can be composted. And we think in the end, it provides a beautiful architectural presence, bringing some biophilic design through a natural material into a space. When either specifiers or manufacturers see this design, usually the first question I get asked is, but what about the heat? Everybody's been trained that LEDs produce heat. It needs to be removed to keep them cool and operating with high efficacy. But the thing is today we have LEDs available at 230 lumens per watt efficacy off the shelf, right? This is not pie in the sky roadmaps and predictions of future efficacy. This is actually available today in quantity at low cost, right? And that's 23 times the efficacy of an old-fashioned incandescent bulb. And it's available in such small form factors, half a millimeter square. We're talking literally grains of sand size light sources. So we have these incredible magical little devices that add the key value to the fixture. And in most linear or planar formats, we've spread the light source out over such a large area, and we are restricted due to energy codes to such low wattage that we simply have such low wattage per area. I mean, in a linear fixture such as this, you're talking 3 to 4 watts per linear foot. You can dissipate that thermal load in free air with no heat sink, and you can certainly mount it into various biomaterial substrates, and it keeps the efficacy plenty high and the lifetime plenty long. Then usually the second question I get is, but what about the fire rating? You're using wood. Ooh, wood, how dangerous is that? Well, first off, most biomaterials can be easily flame-proofed nowadays with bio-based, totally non-toxic flame retardants. And many natural materials are available that are inherently flame resistant or totally inflammable. I'm a bit saddened that when we show natural materials, the first gut reaction is somehow that they're dangerous. All of this adds up to a new revolution awaiting us in LED lighting fixtures, right? We already went through the LED revolution for the past 20 years. Now I think the focus is going to turn to really innovative uses of bio-derived materials. We're seeing all sorts of academic and small startups investigating all new types of biomaterials, from agricultural waste streams to fast growth carbon sequestering sources, uh, really fun things like e-textiles and dissolvable electronics. It's just a very rich, innovative area. And we're going to see some amazing new design concepts and fresh new looks coming out of this material research, really driving the lighting industry to move beyond tired old linear extrusions and sheet metal boxes. We're also going to see a revolution in product marketing where manufacturers really detail the source of the raw materials, how it's processed, what it looks like, what its life cycle will be, and give specifiers the choice in those components. This, for example, is a Spanish manufacturer named Lamp, really beautiful product marketing around material selections. And I think we're going to see a lot more of this in the very near future. The next question I usually get asked is, what about the electronics? And for sure, in modern architectural construction, we are simply drowning in electronics junk. We've loaded up buildings with so many various electronics pieces throughout. It is really difficult to manage. And frankly, there is a very poor story about recycling electronics or converting electronics into a more friendly circular economy approach. I think, though, that the future for lighting has a different tact. We can't eliminate electronics for sure, but we can dramatically reduce the amount of electronics in our lighting systems. And this is going to come because of DC power. In modern buildings, we have three new realities. First off, building owners can pull electricity from solar panels on their roofs cheaper than they can pull electricity from the grid. They can then save that electricity in ever decreasing costs of storage, and everything in a modern building is already DC power. And when you look at large projects like covering the roof of an IKEA or a Target store with acres and acres of solar photovoltaics and trying to be an off-the-grid net zero building project, these small changes in efficacy and these small changes in system costs equal massive cost savings for these large customers. So what we're going to see is a future where we want to take the DC power generated directly from the PV panels on the roof and efficiently funnel that into our LED products with the least number of conversions. We're going to keep it all DC, and we're going to use ever more efficient electronics components that are miniaturized, solid state fault interruption, solid state current control. The power supply itself will go through a revolution. And I think within the next decade, we're going to see that the overall amount of electronics in architectural construction is reduced by a factor of 10 by going to these DC native systems. In many ways, for lighting specifiers, it's going to feel a bit old school at first. You're going to go towards more and more remote drivers, sort of centralized dimming racks. We're going to take the electronics out of the fixtures, and they're going to become centralized and miniaturized. So as a specifier, what concrete steps can you take today to start this sustainable revolution in lighting? First off, there's tons of products already on the market that use wood and natural materials, ceiling systems, lighting systems, sort of hybrids of lighting and ceilings. And that's just a great place to get started. I would also start putting pressure on your lighting reps, your lighting salespeople, your lighting manufacturers to keep this conversation going. So let's play a little game called Stump a Salesperson. The next time a salesperson comes into your office with a new lighting fixture, simply challenge them to send you a list of all the substances used in the fixture by weight. Sadly, this is so uncommon in the lighting industry that the salesperson will probably go running back to the product team, which will then go running back to the engineering team. And at best, they'll be able to deliver you an engineering bill of materials, which does not actually list all the substances in the fixture. That's where we have to get started. We have to press lighting manufacturers to stop and put the effort into understanding what exactly they are putting in these fixtures. And then as specifiers, we have to start learning what is available to us as options in terms of various types of toxic materials or non-toxic materials or energy-intensive materials or more eco-friendly materials. And then as the bonus round, you might challenge them to give you an environmental product declaration for the fixture. EPDs are far more holistic. They look at the complete impacts of the supply chain, the complete impacts of the life cycle of the fixture. But they are very intensive and very difficult documents to build. So I implore you, think about this as one step at a time. Press the manufacturers to simply start acknowledging what's in the fixtures, doing simple things like listing them and publicly putting declare labels on them. And then as an industry, we will progressively move up to more comprehensive sustainability and accountability. And in fact, this is a key problem with changing the industry and the sort of stagnation and the slow-moving transformation right now. You can't take one of these old school toxic products with tons of embodied energy and tons of nasties in them and put them through these labeling programs. It's just too challenging. It costs too much money. It's ridiculous to try. You have to start with a fresh slate, and you have to design products that eliminate most of all that complexity to begin with. And then it makes all of these subsequent labeling programs and sustainability challenges far easier to accomplish. Another topic in sustainability is considering complete life cycle solutions. Often this comes across as sort of a light as a service in architectural projects with leasing plans, pay-per-lux billing, take-back programs, and et cetera. And unfortunately, I'm not a big proponent of this. I just don't see a lot of this working. Frankly, if these concepts would have worked, they would have worked a lot better decades leading up to the LED revolution. And I think a lot of you old school lighting folks will know how hard it was just to get end users to do group relamping in the old days. There's just not a lot of residual value in lighting fixtures at the end of life. And if you don't have that residual value, you really have to pay for it up front. You can't really delay it or spread it out over time. Another challenge to think about is simply repairable LED fixtures. The Zaga standard has been around since 2008, and it is really quite sad that lighting manufacturers did not embrace this. They've been pinching pennies and avoiding modularity, and they've produced fixtures that are disposable junk, basically. You as a lighting specifier can certainly put this down in your boilerplate or look for fixtures that include Zaga. Again, challenge your salespeople. Is this module in this fixture a Zaga standard? And talk to them about it. And as specifiers, you hold tremendous discretion in what you put onto these projects. And I would implore you, don't wait for all of these sustainable standards to come online and for manufacturers to support them in terms of the full product marketing. Just start. Look at these products and in your mind, look at the quantity of materials in them. Do they have any sustainable materials? Give them mental bonus points for being locally sourced or bioderived or biodegradable. Deduct mental points for the distance traveled for these materials. Look at efficient recycling, hold the fixture. Is it obvious that it could be easily disassembled at end of life, 15 years from now? Can it be disassembled and put into local recycling streams, or would it have to be sent far for a disassembly process? Just look at the overall reduction in transport waste from original production to end of life things, mass times volume times distance traveled, any of those you want to penalize. There's another huge benefit to sustainability, and that's creating a sort of local economic advantage. Right? If you have repairable fixtures that local maintenance people can go and actually service, you have smart maintenance programs, you have beautiful factories that can be co-located in residential neighborhoods. You have bio-friendly materials that will, be non-toxic in their initial production, non-toxic in their disposal. You create local revenue streams. You create a localized supply chain. You keep this stuff tied to the neighborhood. And we collectively as an industry have to challenge ourselves. What future are we specifying today? Are we proud of what we're specifying? Are we proud of the future that we're creating? If you're just starting your own journey into the circular economy, I recommend starting with the Ellen MacArthur Foundation. It provides a lot of the basic jargon and lingo around circular economy practices. And check out Bill McDonough. He's a fantastic speaker, very inspirational. He just has a brilliant way of tying economic benefit to sustainable practices. If you're looking to actually implement sustainability on your lighting specifications, look at Building Transparency, which was an effort started by Skanska, the International Living Future Institute, which is the Declare Label program, and there's a variety of other support groups in carbon reduction, non-toxic materials, and so on. So I leave you with this. You hold the keys to the future today. Don't wait. Please get started. Thanks.